Here's another project that we'll do where we're going to take the internal analog to digital converter and measure the temperature of the computer chip and then send the output to the computer with, and we'll read it with um, a program called PuTTY. All right, so this one we're going to use a code example. So File um, and click on Code Example. And not every example works with our particular kit, but and this one needs some editing. So it's C195275 A to D or A to C SAR sequential die temp PSoC 4. Okay, and so you'll create the project. I've already done that, and you will get an you could get a message to update the components, and there is something you absolutely have to do to make sure that it runs properly. Otherwise, it won't build. So I'm just going to, instead of create it, I'm just going to open it up because I've already done that part. All right. Okay. So again, if you want to see the pins, click on the pins. This is the top design schematic, and we actually have to change something in the A to D. And so just right click on that part and configure. And when it comes, it'll be here, internal ref. And there'll be even a warning, meaning this particular CPU doesn't work. So we change it to internal 1.024 volts and click OK. Again, with the pins, sometimes these support multiple projects, and so you want to make sure that these two pins, we're not going to read the output voltages today, right? But the UART transmission pin, you want to make sure that's P05, right? And it is in the documentation, right? There's a whole application note here, and so we should be P71. Did I do that? Not quite sure what's going on here because it's telling me that's the only pin available, right? This was working a second ago. Uh, you know what? Well, let's just try it because this is what I had saved. So I'm going to, everything should be all, actually, because you edit that, you want to build it. All right. Since I've already built it, I guess it was set. Then I'm going to program it. Again, I'm going to click on port acquire, connect. Okay. So I tried it again. It doesn't like it. And I think I'm just going to keep going because this could happen to you. There is the device selector, and we are supposed to be the 485, I believe. This is a bummer. This was working like 2 seconds ago. We're 400 PSoC 41M. Just let me double check this. And so 043 is supposed to be, this is the actual device, the actual chip. And it's the M485. Let's try resetting to defaults, filters. Hmm. You know, I'm just going to put this to, I believe it was port 7.1, and let's try it again. All right, let's program it. It says it was successfully programmed. Should be saved. Okay, so now it's running. You don't see a lot, and we need to connect to the UART, which is going to communicate serially, and you need to know which port. So actually, one easy way is to go to Tools, Bootloader Host, and then it comes up here. This number might be different from you, but KitProg is the programmer, USB UART, and you see it's COM15. There's other things here, but that's the one that we want. Um, don't touch anything with that. Just we know we need COM15. Now download and install and start PuTTY. It's free. Um, so now we're going to use the address COM15. Set it to serial. The baud rate is 115/200. Then come down here to serial, and that's all set. Then come back up to session, and then save it as something so that you can come back to it. All right. And now when I open it, it's running. And so it's reading the temperature off of the chip. Now, if I put my finger on the chip, I should see a rise. There we go. I'm raising the temperature. Now, I imagine that if we go back here and configure the A to D, all right, it's averaging the samples 256 times. So if we actually only averaged it twice, we should see kind of a much noisier signal. So let's just try it. I'm not quite sure what I'll have. I'm just going to stop that because I'm going to reprogram it and it'll probably choke. Okay, looks like it went. I'm going to start PuTTY again. I've had that already saved. Hmm, I don't know. Sometimes when you take out the averaging, you can get that last digit to be somewhat of a random number, but not today. But that's okay. Anyway, sorry about the middle part where it got a bit ugly, but sometimes that happens. Um, and you might wonder, why are there so many choices? Let's see, where is it? Device selector. Is that they make all of these and they all have different characteristics, right? Depending on what you need. So there's the package type. What's the maximum frequency? How much, maybe you want to maximize the RAM. Is there Bluetooth inside the chip? Okay, so if I want a Bluetooth chip, I got to select that one. There's universal design blocks, CAN bus. What kind of A to Ds are there? How many DACs? And so you can just choose the one you actually would use in your particular product, right? And there's even one for automotive qualified, right? So all these down here can go in, they're rated to be put into the harsh environment of an automobile. So that's that. That one doesn't need another video because we were just able to read it out um, through PuTTY. You could also, by the way, use Python to communicate with that, with the UART and plot your data and do whatever you like.